Okay, welcome again to another okotorelearn online session class, and today I'll be treating something on chemistry, which is very important when we are going into organic chemistry. So today I'll be treating something on hybridization. So it will be a very short and not really short, but like it's just a fair class in general, because hybridization is something that it's not really hard and it can allow us to verge into organic chemistry. Are we clear about that? So let us talk about hybridization. What is hybridization? Hybridization is defined as the blending or mixing of 2s and 2p orbitals to form identical hybrid orbitals. So let me re-say that again. I said hybridization is the blending or mixing. So you can call it the blending or mixing, or you can call it the blending or combination, whatever you want to call it. The blending or mixing of 2s and 2p orbitals to form identical hybrid orbitals. So let me recall again. I said hybridization is a blending or mixing of 2s and 2p orbitals to form identical hybrid orbitals. Are we clear? So textbooks like New School Chemistry, they just spoke about hybridization, but they didn't really delve into it. But textbooks like, secondary school textbooks, not undergraduates, but textbooks like extensive chemistry, they really dwelled into hybridization very well. So I will just explain basically what everything means. So now, and I want to make you to note this 2s and 2b that is over here. It is if you recall from the SPDF orbitals, that's under electronic configuration, you recall that we have 1s, we have 2s, we have 2p, we have 3s, 3p. Do you understand that? So now that is where we got this 2s and 2p from. So the orbitals that have been mixed are 2s orbitals and what? 2p orbitals. Are we clear about that? Very good. Okay, so now I think you are able to get the definition for sp3, the definition for sp2, and the definition for sp. Are we clear? So that is very good. Now where we are going to actually, are we clear about that? So now we go to the characteristics of sp3, sp2, and sp. So let me differentiate. We have sp3, we have sp2, and we have sp. Very good. So sp3, sp2, and sp. Now this is the aspect whereby we are going to organic chemistry, particularly when we talk about the aliphatic hydrocarbons. Because when you're talking about hydrocarbons, you have two different parts. You have the aliphatic hydrocarbons and then you have the aromatic hydrocarbons. Are we clear? The aliphatic hydrocarbons are the ones whereby we have the alkane, alkyne. Aromatic is where we have our cyclic hydrocarbons like benzene or ring benzene. Do you understand? So now basically when you look at sp3, sp2, and sp hybridization, the first thing you should know is about their shapes. Are we clear? The shape for sp3 hybridization is tetrahedral. I hope we are together. The shape for sp3 is what? Tetrahedral. The shape for sp2 is trigonal planar. So actually we have trigonal planar, we have trigonal pyramidal, but that is for advanced that is under vast parts theory. The valence shell electron repulsion theory is undergraduate stuff, so it's not for Jamb. So just have at the back of your mind that for Jamb, if you see trigonal planar, trigonal pyramidal, do not be confused. Are we clear? In some cases, if you see sp2, if you don't see trigonal planar and you see trigonal pyramidal, pick trigonal pyramidal. Do you understand? But basically, generally, the shape for sp2 is what? Trigonal planar. But in some cases you can see trigonal pyramidal. It's also correct, but the basic one is what? Trigonal planar. I hope I've done justice to that. And then what is the shape for sp? That is what? Linear. Now actually all these shapes can be explained with the vast parts theory, but I feel you don't really need that. Hybridization is just to give you a little intro into organic chemistry. You don't really need that for now, particularly for your Jamb. Are we clear? So I said sp3 is what in shape? Tetrahedral. Our sp2 is what shape? Trigonal planar. And our sp is what shape? Linear shape. Are we clear about that? Now the next thing you should know about is the type of hydrocarbons that they are. Have been attention. Now our sp3 are always alkanes. Our sp3 are always alkanes. Our sp2 are always alkene or alkenes. Our sp are always alkyne. Are you paying attention? So our sp3 is always what? Alkene. Sp2 is always what? Alkene. Alkene. And sp is always what? Alkyne. What does that mean? So if they ask you, for example, that whatever your name is, because your name is going to be on the app, right? So whatever you see, whatever, what's the hybridization of, do my what I'm saying? What's the hybridization of methane? Automatically, methane is an alkane. When we get to organic chemistry, for you that don't understand, you understand better. So let's just say, what's the hybridization of any alkane? Automatically, what's your answer? sp3. If they ask you, what's the hybridization of any alkene? What's your answer? sp2. What's the hybridization for any alkyne? What's your answer? sp. Do you understand what I'm saying? So basically, whenever they ask you, for example, methane is an alkene. So if they ask you in your Jamb, the hybridization of methane is what? What's your answer? sp3. You don't need to crack your brain about it. Are we clear? You know that your alkenes have what type of hybridization? sp3. Alkenes have what type of hybridization? sp2. Alkyne have what type of hybridization? sp. Do you understand that? I hope that is very clear. Are we good? Now, automatically, now the next thing you should know that every characteristics that alkane have, the sp3 hybridization also has. Are we clear? So, and what are the types of characteristics that they have? Now we move to saturation. Are we clear about that? Now you know that our sp3. Now another characteristic about them is that they are okay. Let's start from the easy ones. They have what type of bond? Single bonds. Are we clear? They have the single bonds. That's something like this, just one bond. Your alkanes are the ones that have just the single bond, while your sp2 have what type of bond? The double bonds. Are we clear? So your sp2, yes, that's alkene. They have what type of bond? The double bonds. Are we clear? And then your alkyne have what type of bonds? That is the triple bonds. Are we clear? So basically, because your alkenes have single bond, your sp3 hybridization will have what type of bond too? Single bond. Because your alkenes have double bonds, your sp2 will have what type of bond too? Double bonds. Your sp, they have triple bonds. So your alkynes have triple bonds. So your sp will have also what type of bond? Triple bonds. Are we clear about that? So I said that our sp3 is tetrahedral, they are alkenes, they have single bond. sp is trigonal planar, they are alkenes, they have double bonds. sp is linear, alkynes, and they have what? Triple bonds. Are we clear? Now another characteristic is that note that your alkanes are what? Saturated. Are we clear? What does saturated mean? You just in one word, just say satisfied. Now there is a particular format I use to explain chemistry. I said that, and I would use that when I get to organic chemistry. I said that any elements that carries positive, that the charge is positive, or its valence electrons are like on the positive side. For example, okay, let me use this illustration. Chlorine. Chlorine is Cl minus, oxygen is O2 minus. I call those negative ones the females. Those are the anions. Very good. Now the cations, I call them the males. Do you understand? Now in organic chemistry, we have one global husband, which is carbon. I will clear about that. And carbon is taking different wives altogether. It's taking oxygen, it's taking hydrogen, it's taking all of them. Are we clear? Now hydrogen is actually possible, but don't worry about that. I will explain later on. Are we clear? So, and because of the fact that it is the male, all the rest are the female. Hydrogen is a female in this world, because hydrogen is not considered as a metal. Are we clear? But it's under group 1, which is a group for the metals. Good. So it is abnormal. So now for alkanes, because the fact that it's using single bonds to attach to different wives, it is satisfied. So we say it is saturated. Are we clear? So that means that if it wants to collect another wife for alkane, it has to release one to get another. So, but don't be confused about it. I will explain it properly under organic chemistry. Are we clear? So we'll say it is saturated. But for alkene and alkyne, they still leave space because they like to do shina. Do you get? They like to fornicate and stuff. So in alkenes and alkyne, they keep extra bonds so that when they see another fine lady in chemistry that they want, they just branch and get the lady. Do you understand? It's just on a lighter mode, but you should understand what I'm trying to say exactly. So just have that at the back of your mind that our sp3, they are what? Saturated. Our sp2 are what? Unsaturated, and our sp are also what? Unsaturated. Are we clear? So automatically you should, that this is giving you an introduction into organic chemistry. Are we clear? So automatically you know that your alkanes, are they saturated or unsaturated? Saturated. Your alkene, are they saturated or unsaturated? Unsaturated. Your alkyne, are they saturated or unsaturated? Unsaturated. I hope that is very clear enough. Okay, now, so as I was saying, so now I just clean up because of the space on the board. So we have sp3, we have sp2, we have sp. So far, what are the characteristics that I've said? I said our sp3 was the shape tetrahedral, sp2 was the shape trigonal planar, sp was the shape linear. Are we clear? What are sp3? Are they alkenes, alkenes or alkyne? Alkane. So if they ask you what is the hybridization of any alkene, what's your answer? sp3. What's the hybridization of any alkene? What's your answer? sp2. Hybridization of any alkyne, what's your answer? sp. Are we clear about that? And I said that which one is saturated? Only sp3. Why the rest are what? Unsaturated. Are we clear? Now the next important point I'm actually going to is the bond angle, the bond energy, and the bond length. Are we clear about that? Now for sp3, sp3 has a bond angle of 109.5 degree. Are we clear? sp3 has a bond angle of what? 109.5 degrees. It's very easy to understand. Now sp2, what's the bond angle for sp2? 120 degrees. Are we clear about that? sp3 is the bond 109.5. What's sp2? 120 degrees. What's the bond angle for sp? 180 degrees. Are we clear? Let me write it down here. So these are their bond angles. Are we clear? So the bond angle for sp3 is what? 109.5, sp2 is what? 120, and sp is what? 180 degrees. Are we clear about that? Now the next one is the bond length. Now next one is the bond length. Are we together? What is the bond length of sp3? The bond length for sp3 is 1.54 Armstrong. This is the way the Armstrong is. Can you see that? That is a all raised power, then you put 0 on top. Are we clear about that? So the bond length for sp3 is what? 1.54 Armstrong. What is the bond length for sp2? 1.34 Armstrong. And what's the bond length for sp? 1.2 Armstrong. So please, majorly what you just try to put at the back of your mind is majorly the bond angles. Are we clear? Particularly for Jamb. I think these are majorly for probably JUPEP level or probably undergraduate. I think you can have more on this. Are we clear? So in the last one, so I've talked about the bond angle, right? I've talked about the bond length. Now the next one is the bond energy. The bond energy. The next is the bond energy. Very good. Now the bond energy. What is the bond energy for sp3? Okay, now for the bond energy, now what is the bond energy for sp3? The bond, now just do it like this. Put that back of your mind like this. That if you notice, the bond angles was increasing from sp3. That's the same with the bond energy. The bond energy is also increasing. Are we clear? Are we clear? So is it, so for sp3, what's the bond energy for sp3? That will give us 346 kilojoule per mole. Bond energy for sp2, 549 kilojoule per mole. Bond angle for sp, 890 kilojoule per mole. Are we clear about that? So what is the bond bond angle bond energy for sp3? So this is right here, 346 kilojoule per mole. What is the bond energy for sp2? 549 kilojoule per mole. What's the bond energy for sp? 890 kilojoule per mole. Are we clear about that? Very good. Okay, and now lastly, now we're almost done actually. So now, remember earlier I said that the characteristics of alkenes are also the ones for sp3. The characteristics for alkenes are the one for sp2. The characteristics of alkynes are the one for sp. Are we clear about that? So one thing you should also know is that our sp3, they have just one sigma bond. Are we clear? So that means your alkenes also have what type of bond? One sigma bond. sp2, they have one sigma, one pi bond. And for sp, they have one sigma, 2 pi bond. Now this is sign for pi, our normal pi, right? But this is sign for sigma. So this sign for sigma is also the sign for standard deviation. That is when we get to maths. Then this is sign for pi. Are we clear about that? And then lastly, our sp3, they carry out what type of reaction? The substitution reaction. Are we clear? Because of why are they carrying out the substitution reaction? Because of the fact that alkanes are already what? Saturated. I already said they are satisfied. Are we clear? Okay, so now I said so first Peter, I said, you know, our alkanes, they're already satisfied. So if he wants to get another wife, he has to release one and get another. He has to break up with one. So that's like substitution. He's substituting that wife for the other. But this alkene and alkyne, they don't need to substitute because they are unitional. They like to fornicate. So they've kept extra bonds already. So that means that they can add another wife to them. So they can carry out what type of reaction? Addition reaction. I hope you understand what I just explained with that wife, blah blah blah. So some guys can just carry out substitution reaction. They break up with one girl, they go to another. But some guys carry out addition. You understand? They're adding different people. Do you get my point? So run away from them. So yeah, so I was just kidding actually. Are we clear? So now I said sp3 carry out substitution reaction right now. You know, I said for sp2 and sp, that means they can both carry out what? Addition reaction. Are we clear about that? So addition reaction. Are we clear? So they can both carry out addition reaction, but they can also carry out substitution reaction. So they can carry out addition reaction and what? Substitution reaction. So over here too, and substitution reaction. Are we clear about that? So you understand what I'm saying? So just have this at the back of your mind towards going to organic chemistry, that our sp sorry about that, that our sp sorry our alkanes, yes, our alkanes are what? Saturated. They can carry out a substitution reaction. They are, and what's their shape? They are tetrahedral. Okay, our alkenes, they can carry out addition and substitution reaction. They can also they are also unsaturated. Our alkynes are also unsaturated. They can also carry out what? Addition and what? Substitution reaction. Are we clear about that? So this is just preparing your mind towards what you have to expect in organic chemistry. Are we clear about that? So let me recap just everything I've said, because I've said earlier that this hybridization is more of just a short class, just a short intro. I think it's only on extensive chemistry that you can see something on this. I don't know about many other textbooks, but those I've seen already. So let me just give a recap again. I said hybridization is a blending or mixing of what? 2s and 2p orbitals to form what? Identical hybrid orbitals. Now I define the types of hybridization. We have sp3, sp2, and sp. Okay, so now I've explained hybridization in general. So let me recap to you again. I said define it for me. Define it, say it, make sure you say it correct. It's a blending or mixing of what? 2s and 2p orbitals to form identical hybrid orbitals. Now we have three major types of hybridization. We have three major types. And call it types or forms anyhow. So the first one, we have sp3 hybridization. Second, we have sp2 hybridization, and the last one we have sp hybridization. Are we clear? So I said we have three types of hybridization. The first one is what? Sp3. The second one is what? Sp2, and the last one is what? Sp. And the definition is very simple for the types of hybridization. Are we clear? Basically, in sp3 hybridization, look at this, please. I want you to look closely at this. I want you to look closely at this. What is the power of S over here? 1. Am I correct? What is the power of P over here? 3. Do you understand? Because it's what? sp3. Now recall when I defined hybridization for you in general, I said it's the blending or mixing of what? 2s and 2p. I did not put a number there. Am I correct? To form what? Identical hybrid orbitals. So if we have to define sp3 hybridization, so let me write the hybridization here. So we have sp3 hybridization, sp2 and sp. Now if I'm to define sp3 hybridization, I would define it as the blending or mixing of, what's the power of S here? 1, 2s. And what's the power of P here? 3, 2p. orbitals. Do you understand? Because from the definition, I said hybridization is a mixing of what? Of 2s and 2p. So if we are defining sp3 is the mixing or blending of, what's the power of s here? 1 abi, 1 2s. What's the power of p here? 3 abi, and what? 3 2p. To form, now 1 plus 3, what would that give us? 4. Now you know in the normal definition it was to form identical hybrid orbitals, but here we have to have a number. So 1 plus 3 give us what? 4. To form 4 identical hybrid orbitals. So if we are to define so if we are to define sp3 hybridization, sp3 hybridization, let us go, is defined as the blending or mixing of what? 1 2s and what? So sp3 hybridization is the blending or mixing of what? 1 2s and what? What's the power of p here? 3. That's what? 3 2p orbitals. To form 1 plus 3 was what? 4. To form 4 identical hybrid orbitals. Are we clear? So let me define. Why am I saying design? So let me define it again. So I said our sp3 hybridization is what? Blending or mixing of what? 1 2s and 3 2p orbitals to form what? 4 identical hybrid orbitals. Very simple. So now, okay, now so move to sp2 hybridization. Now in sp2 hybridization, I would love you to define that for me. Automatically think, what is the power of s here? 1. What's the power of p here? 2. So automatically sp2 is the blending or mixing of what? 1 2s and 2 2p to form what? 3 identical hybrid orbitals. So let us write that down. So we have sp2 is the blending or mixing of what? Of 1 2s and 2 2p to form, what's 1 plus 2? Everybody? 3 identical hybrid orbitals. So please, I hope that is very clear enough. So I said that our sp2 hybridization is a blending or mixing of what? 1 2s, because what's the power of s? 1 2s and 2 2p abi 2 2p orbitals, sorry, ensure you add orbitals to form what? To form 3 identical hybrid orbitals. Very easy. Are we clear about that? So now lastly we have sp hybridization. So I would love you to define sp hybridization for me. So define it. Make sure you define it. Define sp hybridization. Whatever you define, I think you are correct. So you could. So now, what is sp hybridization actually? Sp hybridization will be the what? The blending or mixing of what? 1 2s and 1 2s and 1 2p to form how many identical hybrid orbitals? 2 identical hybrid orbitals. I hope that is very clear. Very good.
Want more interesting videos on this? Go to our website at okotorelearn.web.app and upgrade to premium to experience more videos, use CBT, review past Jamb remix questions, and discuss with tutor for questions and answers.